Hi, greetings and welcome back to Roy's Desk with another video. Well, if you have seen this video, then you might be waiting for the sound test of this board, and this video is mainly going to focus on the power test and the sound test of this LM3886 board. We will also talk about some mistakes that are there in the PCB. So without wasting any further more time, let us quickly get started. So everything is soldered right in place now. It looks quite nice as per me. And if you have seen my previous video, there I have said that I messed up this JST connector in here. The footprint is way too small. It's 1.25 mm, the pitch. But luckily and fortunately, as you see in this website, this type of JST connector is already present. And this is exactly the right pitch, 1.25 mm. So I ordered couple of this. And these are the ordered parts. So if I show you this is very small in size, but it will work because this is the input side and it's almost negligible current that is going to get fed to this connector, and this is the other side of the connector. So I have ordered 10 pieces of this, and again I made another mistake. So if you see the board, it fits perfectly in this, but the way if you fit this in here, the wire will connect like this, and that means the negative side is the red wire and the positive side is the black wire, which is again kind of going to mess around later. So I have to fit it like this so that the red wire is the positive and the black wire is the negative. Nothing happens, it's just that the silk screen of this looks a bit weird if I place it like this, but it will work. So let's solder this, and then we are going to go into testing, sound testing and power testing. Okay, so I powered it on and there seems to be no magic smoke, nothing. But I could find another PCB mistake. Now if you see this board, the capacitor positive terminal is marked in here where this resistor is connected and also this diode is connected. Now these three components are part of the delay circuit, and this is how I connected the capacitor. But if you see the circuit diagram, you see this positive terminal of this capacitor is connected to the power ground and the negative terminal is connected to the resistor and the diode end. But in here, the negative terminal is connected to the power ground and the positive terminal is connected to the resistor and the diode end. And this is why I was not getting any sound or anything. It was just no magic smoke, nothing, and it was just dead silent. Then I tried sorting out this diode in here, this inner diode in here, and it started working. So then I came to know that okay, there is this silk screen error in here. This positive should be in here rather than in here, and then I replaced the board with the capacitor negative terminal in this side. So this is where the positive should be and not in here. So this is another mistake. Now I've corrected all the mistakes and updated my PCB. I'll show you that PCB in the end of the video. Now also I have got this Bluetooth module from the Sound King. This is one FM plus Bluetooth module, and I'm going to test this for the sound testing of this board. I have connected this in here. There is one issue with this board again. The output is very clean and clear. I'll show you in a while. But the peak to peak voltage that it outputs at the maximum volume, it's very low. It's close to 0.3 volts peak to peak, and that is very low for this one to go into clipping. So we need one preamplifier circuit in here. So I made just one preamplifier circuit. This doesn't do anything else. This just puts some gain into the circuit. So I'm outputting 1 kHz sine wave from my phone. It's connected to this module. It is on, and you can see that the phone volume is also full. And the output that we are getting in here is 0.3 volts peak to peak or 300 millivolts peak to peak at 1 kHz. And definitely we will need one preamplifier circuit now to boost this to at least 2 volts peak to peak so that we can reach the maximum output power of this one. So let's not delay and just directly go into the testing of the board. Okay, so I made all the connections. It's dead silent. The connection is pretty much simple. The output from this Bluetooth module is going into the input of this amplifier circuit, preamplifier circuit, and the output of this preamplifier is going into the input of this amplifier. Now one point to note, as I have told in the PCB design video, that there is no connection of the power ground and the signal ground in this PCB. So if you try to understand the connection, it's pretty simple. So the output from this, the two wires plus and minus, the minus directly goes to the power ground, and there also we have plus and minus in the input. The minus directly goes to the power ground, and we have plus and minus in the output also. For the speakers, we have the minus directly connected to the power ground. So all the negative connections directly goes to the power ground so that there is no ground loop created. So now let us start something. As you could see, it's crystal clear sound. It's expected from this LM3886 IC. So what's remaining is the power testing of this. Now for power testing, you can definitely check this video out in here where I've tested this board. But still, I'll do one test with 19019 and 4 ohms. We will check what is the output power of this. We definitely know, if you have seen my previous video, what is the output power at 4 ohms 19019 supply. But still, we'll check how this board performs. So I made all the connections, and I'm not going to explain the connections again because this is what I do in every video. And if you want to know more about the connections, please do watch my previous videos. And I've switched it to 4 ohms in here. For those who are curious about the voltage that I'm feeding to this, it is 25.5 volts plus minus DC. So total of 51 volts. Total of 51.1 volts. Now let me slowly increase the amplitude of the signal generator so that we can see clipping, and we'll note that we peak to peak voltage at clipping. Okay, there is our clipping in here. Nice and clean clipping on both the rails, the top and the bottom. And if you see, we are getting somewhere before clipping. If you take, whoa, it's jumping around, but it is 42.4 volts. Yeah, 42.4. And for those who want to see what is the voltage drop at the point of clipping, it's 24.1 volts now. Earlier it was 25.5 volts. Okay, so it was 42.4 volts V peak to peak divided by 2.828. That gives us our VRMS. It's close to 15. So square of that, this is our VRMS square divided by the resistance, that is 4 ohms. So it's 56.2 watts. And now I wonder, it's actually more than this. If I remember correctly, it was around 53 or something. It's 56.2 watts. So now I think it's time to wrap up the video, but before wrapping up, so this is the updated PCB design. I made it more compact. I made some minor changes to the position of the components here and there. I corrected all the mistakes that I have talked about earlier. But yeah, I'm not going to order the PCBs again. It's pretty costly for 5 to 10 PCBs, 1000 rupees. I'm just gonna use the previous PCBs only. This is just the updated design. In future, if I make some more amplifiers with the LM3886 IC, or somebody wants the Gerber file of it, so this is going to be the circuit. Now it's time to wrap up the video. In the next video, I will mostly talk about the stability of the board, LM3886 board. So thank you for watching the video with all the patience. If you have any questions, please do drop that in the comment section. Please do like, share and subscribe to my channel, and also press the bell icon to get notifications whenever I upload a new video. We will meet again. Till then, bye bye.